All right. So we are now starting chapter 3, which goes back to the book. We're going back into the book because doing this online, you wouldn't learn anything. Okay? You'll just guess and check. You'll just guess at the answers and not learn it. So we are going back into the book where you have to use your brains. All right. So these are basic ways to change things into sines and cosines. Cosecant is 1 over sine. Secant is 1 over cosine. You should know that by now. If you didn't know that by now, well, wake up and smell the coffee. You need to know that. We could turn tangent into 1 over cotangent most of the time. No, in this chapter, we'll turn it into sine over cosine. Now, every once in a while, we'll turn sine into 1 over secant or cosine into 1 over, or sine into 1 over cosecant and cosine into 1 over secant. Okay, but most of the time we'll be turning cosecant and secant into sines and cosines. Even though cotangent is 1 over tangent, most of the time we'll be turning cotangent into cosine over sine. Okay? Now, what's new is our Pythagorean identities, which we'll get to in our second lesson today, not our first. But if you square sine and square cosine, wherever you're at on the unit circles, doesn't matter. Wherever you're at, if you square sine and square cosine, it'll always equal 1. From that, if secant squared is equal to tangent squared plus 1, and cosecant squared is equal to cotangent squared plus 1. Okay? Those are really important. We'll use those a lot this chapter. A lot. And then the odd-even identities we won't use very much, but you'll have to understand that the sine of negative x is equal to the negative sine of x. And you're going, what you talking about, Bishbach? It is this. The sine of negative pi, okay, well, negative pi probably isn't a great. The sine of negative pi over 2 is down here, 90 degrees, right? Okay. So that's the negative of sine of pi over 2. Because if you put a pi over 2 in each of these, okay, the sine of pi over 2 is 1. The sine of negative pi over 2 is negative 1. The sine of negative 45 degrees is negative square root of 2 over 2. That's the opposite of the sine of 45 degrees, which is square root of 2 over 2. If you go over to 135 on your unit circle, the sine of 135 degrees is square root of 2 over 2. The sine of negative 135 is negative square root of 2 over 2. Okay? So that's how that works. But cosine's a weird one. The cosine of negative x is the same as cosine of x. So the cosine of 45 and the cosine of negative 45 are going to be the same thing. The cosine of 135 and the cosine of negative 135 are going to be the same thing. So whatever cosine is, secant is also follows the same. Okay? So odd and even functions. So, what are we doing today? Well, we're turning, in this first section, we're turning sine, or things that aren't sine and cosine, into sine and cosine. So if we had secant of x divided by tangent of x, how can we simplify that? Well, to simplify this, we want to turn things that are not sine or cosine into sine and cosine. So cosecant from your note card equals 1 over, I called it cosecant, but I meant to say secant. Secant equals 1 over cosine of x. Tangent in terms of sines and cosines is sine of x over cosine of x. Now what did I do? I just made a complex fraction. That's not very nice of me. But I want to get rid of my complex fraction. One way to get rid of a complex fraction that we'll use most of the time in trig is multiplying by the denominator of the denominator. What's the denominator of the denominator? So we'll multiply the numerator by cosine of x and the denominator by the cosine of x. These will cancel and these will cancel. And I'm left with 1 over sine of x. 1 over sine of x I know is cosecant of x, but I'm going to tell you, let's leave these in terms of sines and cosines right now. Okay, so we're going to leave these in terms of sines and cosines for now. so we understand how to turn them into the proper ones. Okay? Let's say we have sine of x plus cotangent of x times cosine of x. And let's see what that turns into. Okay? Let's see what that turns into. Now, if you already have sine and cosine, you leave it as sine and cosine. So sine of x plus, what's cotangent? Don't say 1 over tangent. Say cosine of x over sine of x. Because we want to turn these into sines and cosines times cosine of x. Well, that doesn't look that much more simple. Cosine of x is really cosine of x over 1 here, right? So if we multiply these together, I get sine of x plus cosine squared of x over sine of x. Still not all that simple. Now what I want to do is make one fraction out of that, because I got a fraction and something that's not a fraction. Let's make one big old fraction. Okay? To make one big old fraction, this is sine of x over 1. What's my common denominator? Sine of x, right? So I'm going to multiply the top and bottom of this one by sine of x. So I get sine squared of x over sine of x plus cosine squared of x over sine of x, which is sine squared of x plus cosine squared of x over sine of x. And if you think you're done, you go, I'm done. And then I'll say, yeah, but you're wrong, because you're not done. What could I replace sine squared of x plus cosine squared of x with? 1. This is a Pythagorean identity. The answer is 1 over sine of x. So this stuff works down to be that. 1 over sine of x. Let's do this one. What's secant x the same as? 1 over cosine of x. So you have cosine of x over 1 over cosine of x plus sine of x over, what's cosecant the same as? 1 over sine of x. Again, I've created complex fractions. That's not very nice of me. So let's get rid of my complex fractions. How can I get rid of my complex fraction in the first one? So we're going to multiply top and bottom by the cosine of x. So the cosines cancel here, so I get cosine squared of x. Here I'm going to multiply top and bottom by sine of x. So I get sine squared of x, and then these two cancel. So what's cosine squared of x plus sine squared of x? 1, because it's one of your Pythagorean identities, and that works out to be 1. Cosecant of x plus 1 times cosecant of x minus 1. When you see things like that, what 4-letter F word do you think of? Foil. Foil. If you thought of another 4-letter F word, you're naughty kids. Don't be a naughty kid. Foil. So if we FOIL this, I get cosecant squared of x. Outers and inners are going to do what? Cancel. These are conjugates. Okay, remember from Algebra 2, a conjugate is the exact same binomial except for it has the opposite sign in the middle. Conjugates. Okay? So outers and inners are going to cancel. Last times last is? Last times last is? Okay. Now, cosecant squared of x minus 1, does that look anything like one of your Pythagorean identities? Which one? You got something that looks like that, right? So according that's exactly what you said, right? Just subtract 1 from each side? Yeah. So if we subtract 1 from each side, cosecant squared of x minus 1 equals cotangent squared of x. Right? Hey, this is the same as this, right? So I can replace this with cotangent squared of x. Now, if I tell you to write in terms of sines and cosines, then there's just one more step. What's your last step? What is cotangent the same as? So it would be cosine squared of x over sine squared of x. And that is now written in terms of sines and cosines, and that is what it would be equal to. This is FOIL again, but we're going to wait just one step to FOIL it. The reason why I'm waiting one step is I see a cotangent times a sine, and I'm wondering, maybe I can simplify that a little bit. How could I simplify that a little bit? And then what can I do to that? Since sine is being multiplied by cosine over sine, it's not the distributive property, since it's on the inside of the parentheses. Since sine is being multiplied by cosine over sine, what can I do? So I have cosine of x plus 1 times cosine of x minus 1. And now, what's the four-letter F word that I do? FOIL. Cosine squared of x. Outers and inners do what? Cancel because they are what? Conjugates. 1 times negative 1 is negative 1. Cosine squared of x minus 1. That's as simple as it can go, right? No. Because we know there's a Pythagorean identity out there that says sine squared plus cosine squared equals 1. What can I do to both sides? Well, I can get cosine alone by subtracting sine squared of x. So cosine squared of x equals 1 minus sine squared of x. And then how can I make it look like cosine squared of x minus 1? subtract 1 from each side, so I get cosine squared of x minus 1 equals negative sine squared of x, and so this is equal to negative sine squared of x, and now it's just one term. I go from this complicated thing all the way down to this. Okay, so that's what we'll be doing in our first set of exercises, which should not take you too long. On page number 165, we're doing 7 through 14 all. 8 problems to start out with. Get to work, please.